Excuse me, sir.
Yes.
So you gave a question in the last class. What are the answers for that?
That I will share. Actually, it is requested to the CR. Kindly. Okay, I had shared it. Had I written it on the screen?
Yes, sir. You wrote the question on the screen.
Okay, I'll share. I'll share the solution. Okay, let me finish these two things first. Okay, this thing first. I will share it. Don't worry. Whatever is given, I'll share it. So today we will be looking into shortest remaining time first, which is a primitive version of SJ. That means what? Whenever a new process arrives, okay, whenever a new process arrives, okay, the short-term scheduler will be running or will be doing context switching. Okay, for example, suppose P1 is executing, P2 arrives, okay, and we see that the burst time of P2 is less than the remaining burst time of P1. Then what will happen? P1 will be preempted and moved back to the ready queue or the wait state, and P2 will be executing. Okay, so it happens one by one. So as whenever a new process arrives, now suppose if all process available in ready queue, okay, then if all processes available in ready queue, then it will work in non-preemptive manner. So this will be clear through an example. Let us take an example. Okay. So we have this. There are 6 processes. This is my process ID. Then I have arrival time. First time. The arrival time is 0, 1, 2, 3, 4, 5. First time is 8, 4, 2, 1, 3, 2. Okay, fine. So now see. So this is how it is there. So we have now. If I am
Sir,
talking about
the screen is paused.
pardon,
The screen is paused.
screen is paused. Let me see. I hope it is visible now.
Yes, sir.
Yes, sir.
Okay. So this is the process ID. Okay. Now if we are talking about the Gantt chart. Okay. Now see. So how this will work? Okay. If we are talking about the Gantt chart, it starts from here. Okay. Like this. So at time 0, what is there in my ready queue? Only P1 has arrived.
P1, sir.
P1 will start working till time 1. At time 1, what we have? We have P1 equal to 7 and we have P2 equal to 4 in the ready queue. Yes or no? Is
Yes,
this
sir.
clear?
Yes, sir. Yes, sir.
This is the remaining time of P1 and this is the burst time of P2. Now what will happen? P2 will start executing. Okay. P2 starts executing till time unit 2. At time unit 2, what we have? This changes. Okay. This changes. So we have P3 is P2 is equal to P2 is equal to 3. Okay. And P3 is equal to 2. Correct?
Yes, sir.
So P3 will start executing. P3 will start executing. And what will happen? P3 will start executing. It will go till 3. At time 3, what happens? Again, so our ready queue changes. What we have in ready queue? We have in
P4.
ready queue like this, equal to 1. So we have a tie over here. Yes or no? So what
Yes,
will be
sir.
executed? P3 will be again executed till what?
4,
Four.
sir. Come, 4.
Uh, so now at time 4, what happens? P3 is gone. Okay. We have P4 equal to 1 and P5 equal to 3. Okay. Now what will happen?
P4 will execute.
P4 will be executed till what? Time 5.
5, sir.
Okay. So P4 is also out. Now what we have? What we have in ready queue? We have in ready queue as P equal to 3, P6 equal to 2. Now what will happen?
In primitive
P6
way, sir.
will
Non-primitive.
Now it will be in non-primitive mode, just as SJF. So what will be executed now? From 5,
P6, sir.
P6 will be executed till 7. Then
Then P2, sir.
P2 will be executed till 10.
P5.
And then
P5
5 till
P5
13, P1 till 20.
13. And then P1 will be executed till 20.
20.
Okay. Now, so what we have to do is process ID button 2, 3, 4, 5, 6. Arrival time, exit time, create time, WT, waiting time. Okay. So arrival time is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. Okay. Exit time of 1 is 20. Okay. Exit time of 2 is 10. Exit time of 3 is 4. Exit time of 4 is P4 is 5. Exit time of P5 is 13. And exit time of P6 is 7.
7.
So your turnaround time is 20, 9, 2, 2, 9, 2. That is exit time minus arrival time. What is your waiting time? Waiting time is your burst time. This will be 12. Okay. 9 minus 5 is 9 minus 4. Sorry, second one is 4. I hope so. 4. This will be 9 minus 4 is 5. This is 0. Turnaround time minus burst time. This is 1. 2 minus 1. And we have 9 minus 3 is 6. 2 minus 2 is 0. Is it clear?
Yes, sir.
Yes, sir.
So average TAT will be equal to 6, 15, 24. 6, 15, 24, 44 by 6. And average waiting time will be equal to
24. 24 by 6.
4 units. This will be 7.33 units. Is it clear?
Yes, sir.
So just one doubt.
Yes.
Yes. What is it?
So can you please scroll up to the Gantt chart?
Yes.
Yes. So the process P3. So you have
Yes.
done it like 2 and 3, and then you made another division, and then continue the
yes.
same process.
Yeah. That is for understanding. What we can do is we can do it like this completely.
Okay, sir.
This is for your understanding. Okay. See, at time 3, what happens? At time 3, what we have?
P4 arrives.
Your ready queue. Your ready queue will be having P1 equal to 7, P2 equal to 3, P3 equal to 1, and P4 equal to 1. Okay, this is there in my ready queue. So P3 and P4 has the lowest remaining time, burst time. What is that? 1 and 1. So we have a tie. So in case of tie, what we are going? We will be preferring the process ID, lower process ID, P3. So we'll continue execution. So you can do directly this, or you can do like this also. Both are okay.
Okay, sir. Thank you, sir.
Okay, so now we'll do one more. Now, can you calculate the response time of all the process over here? Response time of P1, P2? Tell me.
Sir, P1 का 0.
What is the formula of response time?
The
Time.
first time.
The
Sir,
first time
CPU
when the
The
process
first
gets
time
CPU
when the process
Time
get the CPU.
minus
first
arrival time.
minus 50.
Arrival time.
Okay. So similarly, you can calculate what will be of P1,
Sir, 0.
P3.
Sir, P3 is 0, sir.
Okay. Fine. So you people know this how to calculate response time. So let us solve one more problem. Okay, with related to shortest remaining time. Okay. So this is this problem. This one. Hmm. Solve this one. You need to calculate average waiting time and okay. This also calculate average waiting time and TAT. So this is question number 1. This is question number 2.
Sir, can you scroll up once?
Yes, sir.
Solve for question number 1 first.
Okay, sir.
I'll write it again.
Sir, please solve question number 2.
Copied?
Yes, sir.
Five unit.
Sorry, this will be also 9. It's 9. Yes. तो यहाँ पे execute होगा. So this is how it will work. Is it clear? This one.
Yes, sir.
Yes, sir.
This was question number 1. So we have average waiting time is equal to 5 units. Yes?
Yes, sir.
So this is my second question. Question number 2. So if I am finishing this week, hopefully this week scheduling will be over and we will be moving to synchronization. So next week we'll have a class test on scheduling. 0, 2, 1, 4, 2, first time, 1, 4, 2, 6, 3, 1, 4, 2, 6, 3. So, P4, 1, okay, and P4 equal to 5, P2 equal to 4, 2, 2. Now, 2, 4, and this is equal to 6 per in. Okay.
Sir, at time 3 P1 will arrive.
P2 will work up to 3. At 3, what we have 2 remaining minutes. So 1, 2, 1 as 1. So 1 to 4. And this is equal to 2. Is equal to 2. So now we'll have 2, 6, 3, 8, 5, 11, 4, 16. P1 exit time is 4. P2 exit time is 6. P3 exit time is 8. P4 exit time is 16. P5 exit time is 11. 1, 5, 4, 16, 9. So 1, 2, 10, 6. Is it clear?
Yes, sir.
Yes, sir.
10, 30, 35. 35 by 5, 7 minutes. Average waiting time will be 19 by 5. That is 3.8. Is it clear?
Yes, sir.
Yes, sir.
So this question number 3. This is your try at home. Using SRTF, calculate the time of process P3. This is your question. Please copy it. Next class I will solve both the home try at home. First thing I will do that try at home. This one and the previous one, so that you can match it. Have you copied?
Yes, sir.
Sir, can you scroll up
Scroll.
in the Gantt, sir, to the Gantt chart?
ये वाला.
Yes, sir. Yes, sir.
Okay.
Sir, a time is equal to 2. P5 having lesser burst time than P2, sir, arrives. So, sir, P2 will come out from the queue, and then sir, P5 should go into the queue.
नहीं, P2 का 3 रहेगा. Time 2.
Sir, P5 arrives.
Yeah, just a minute. P4 का 5 remaining है. P2 का time 2 पे 3 remaining है. P5 का 3 remaining है. कैसे P2 से lower burst time है? यहाँ this we are having a tie over here.
Okay, sir. Okay, sir.
Tie हुआ ना जी?
Sir, then P2 will execute. Okay, sir.
Then if there is a tie, what is the thing we have to go for?
Lower process ID.
Process ID. What is your low process ID? P3. Why? And then what will happen at time number 3? At time number 3, at time unit 3, what happens? This reduces to 2, and we have what? 4 पे क्या है? P3. Sorry. At time 3, sorry, time 3 we have P1. P1 equal to 1. So where P1 is executing. And time 4 onwards, what will happen? This will be SJF. Yes or no?
Yes, sir. It will be SGF.
Till time 3, what it is? It is SRTF.
TF.
ठीक है, ये क्वेश्चन नंबर 2 और क्वेश्चन नंबर 1 ये गेट में आस्क हुआ. These are gate questions. Have you written this one?
Yes, sir.
हाँ, चलो अब नेक्स्ट हम लोग चलते हैं राउंड रॉबिन पे. Next is RR scheduling. So this is known as round robin. Okay, this is primitive version of FCFS. ठीक है, ये कॉन्सेप्ट है, कॉन्सेप्ट यूजेस कॉन्सेप्ट ऑफ टाइम शेयरिंग. ठीक है, सो time slice is defined for every process. Time slice is defined, known as TQ, that is time quantum or quantum. ठीक है, and so process execution is cyclic. Process execution is like cyclic. Execution is cyclic. So this is the concept. We have ready state means which queue we are talking about?
Job queue.
Job queue.
So this is the logic. Okay. So ready state, then process will be taken out one by one. Then it will compare. If burst time is less than time quantum, then it will execute till completion and go for termination. If burst time is not less than time quantum, it will execute for that time quantum. Time quantum is finished, then again it will see whether the process execution is over or not. If it is over, it will go for termination, or else it will go to the ready state. Okay, this is how it works. Okay, so generally, this is, it gives us a fair allocation of time, job fair allocation, and also this solves in some way, it solves starvation also. Okay, that was there in our convoy effect, is our starvation. Let us take an example over here, and then we'll see this flow chart. Okay, so we have this. And what we are doing, we are defining a time quantum of 4 units. Okay. Now, so let us start solving. So here we will draw a ready queue. Okay, and here we'll have our Gantt chart. So at time 0, okay, what we have? We have P1. P1 will execute till time 4. Okay, at time 4, what happens? What we have in ready queue? We have in ready queue as what? P2 equal to 6, P3 equal to 3, P4 equal to 3, okay, and
P4 equal to 1, sir.
sorry, P4 equal to 1. I am writing the arrival time. P4 equal to 1, P5 equal to 5, P6 equal to 4, and we have P1 equal to 1. Yes?
P6 is not arrived.
Sir, P6.
Time 4. So we have P2, P3, P4, P5, P1. Okay, this will be 6, 3, 1, 5, and what we have 1. Okay, so this will be our ready queue. So we have P3, P2, P3, P4, P5, and P1. Now what will happen? P2 will execute till 8. P2. Okay. So what will be the ready queue now? At 8. What will be the ready queue? We'll have P6, 4. Okay. P6, 4, and we will have P2. How much? 2. And this we will remove. So at 11, what is happening? P3, 8, 11. So what is happening? In case of P3, this part is executing for P3. Yes or no? For P1 and P2, this part is executing. So P3, what is the burst time? P3 burst time is 3. What is the time quantum 4? So it will finish execution and it will go to termination state. Now what will happen now over here? This is removed. This is our ready queue. Okay, then in the next time, what will be next executed? P4. P4 will be executed to 12. Now again, P4 is following this one. Yes. Okay, so P4 also goes out. P4 also goes out. So we are queue. Now we have this queue. Okay. So what we are having now? We are having so we have P5, P1, P6, P2. Okay. So what will happen now? So in next time quantum, P5 will be executing till 16. Now what happens? Now we will have P5, 1. So this becomes our ready queue. So this also is removed. So finally we have this as our ready queue. Yes or no? So then P1 will be executing till 17. Then P6 will be executing till 21. Then we'll have P2 executing till 23. And again we have P5 that is executing from 23 to 24. Okay, so at time 17, what happens? This goes time 21. This goes time 23. This goes time 24. This goes. Is it clear?
Yes, sir.
Now what we need to
Excuse me,
do?
sir.
Yes.
I did not understand the P1 and P6 part here.
Yes, sir. P1 and P6 is executed, sir.
Yes, sir.
P1 and
P6 from 16 to 21.
Yes, sir.
Now see, for that, then if we have, now what is happening when a process has a burst time remaining after time quantum, it is moved to the last of the queue. Okay. See, for example, in ready queue at time 4, what we have? At time 0, we had only P1 as 5. Okay. But at time 4, what we had? We had P1, time 4, what we had? We had P2, P3, P4, and P5. P2 was having 6 burst time, P3 was having 3 burst time, 1 burst time, 5 burst time. Now P1, as I said, it will be following this one. Time quantum execution for time quantum, TQ finished. Is execution finished for P1? No, P1 requires one more time unit. So what will happen? P1 will be moved again to the ready queue. So where it will be moved? So it will not be in the first. It will be moved over here after, sorry. P5. P1 will be having one like this. Okay, so this is empty over here. Is it clear now? Now.
Yes, sir.
Okay, now. So at time 8, what happens? At time 8, we have at 8, at this point of time, we have time quantum is finished. Is P2 finished? No, P2 is not finished. P2 requires what?
2 units.
2 more units. Yes or no? At time 8. Okay. When we are talking about time 8, P2 is not yet finished. Okay. And it requires 2 more units. So we will have P3, P4, P5, P1, P2 will move to ready state. Again, it will be pushed to the last of the queue. Like this. Okay. And this goes on.
P6 enters the.
So at time 8, what happened? P6 enters, at time 6, sorry. That's wrong. So 8, at time 6, what happens? P6 has entered. P6 has entered with 4 quantum. And at time 8, what happens? P2 is moved to the end of the queue, which has 2 units remaining. Is it clear now?
Yes, sir.
Yes.
So this is at time 8. What happens at time 11? This is executed.
Yes.
So which part will be executed? This part of the flowchart will be executed. This directly goes to termination. Okay. Then at time 12, what happens? This is executed. Yes or no? So what is our queue position? This is our queue position. Okay. Now at time 16, what will be the queue looking like? Time 16, the queue will be looking like this. P5 is 1 and this goes off. Okay. Then, as I said, it is first come, first serve with preemption. So what will be executing now after time 16? What is there in the queue? First come, first out. This is FIFO. First come, first out. What will be executing? P1 till time 17. So has P1 finished?
Yes.
Yes,
This
sir.
goes to termination. What happens at 17 till 21? P6. Has P6 finished?
Yes.
So
Yes,
this
sir.
goes to termination. Now at 21, we will have P3, P2. So at 23, is P2 finished? Yes. P2 is not going to ready state. These 3 are terminated. What is remaining? P5. So P5, is it clear now? 15, 16 onwards?
Yes, sir.
Yes. Any doubts?
No.
Zero, 1, 2, 3, 4, 6. Exit time of 1 is 17. Exit time of 2 is 23. Exit time of 3 is 11. Exit time of 4 is 12. Exit time of 5 is 24. And exit time of 6 is 21. Now what is TAT? 17, 22, 9, 9, 20, 15. Waiting time 7, 12, 16, 6, 8, E minus 5, 15, 11. Is it clear?
Yes, sir.
Sir.
Your average waiting time.
$68.
तो मुझे भी डबल चाहिए ले लियो खिंचा के डबल लेस पकड़ डबल डबल करो एक तो लावन तो ले लियो
So is this clear?
Yes, sir.
Now solve this one.
Sir, will you please show the algorithm, please, sir? Okay, thank you, sir.
So TQ is equal to 2 units. Calculate average waiting time. Do it. Hmm. 5.8 is your average waiting time. Now see. So the answer is your 5.8. So how this goes? Let me explain for everyone. So we have ready queue over here at time 0 is P1. We have ready queue as P1. First time is 5. Okay. So at time 2, what happens? P2, P1 goes to ready state. Okay. So at time 2, what we have? P2 has burst time of 1. P3 has burst time of 1. And again, we have P1 has burst time of 3 remaining. Yes. Now, what happens? P2 will execute. This is 3. P2 will execute. Okay. At time 3, what we are having? At time 3, P4 comes with burst time of 2. Okay. So P4 will execute till time 4. What happens at time 4? Time 4, P5 also comes with burst time 3. And at time 4, P2 is again moved to ready queue as 1. Okay. So at time 4, what happens? P3 goes for execution, and at time 5, what happens? P3 is out of the ready queue. What happens now at time 5? P1 is again executed till time 7. What happens at time 7? We have
P4.
P1 is at the end of the ready queue. Yes or no?
Yes, sir.
So this is our ready queue now. P4, 2, P5, 3, P2, 1, P1, 1. Okay. And then at 7, what happens? P4 executes till 9 and this goes off. Okay. Now what happens? At 9, P5 will execute till 11. What happens at 11? At 11, your ready queue looks like this. P5 is 1. Okay. Clear? So first P2 will be executed till 12, goes off. Then P3 will be executed till 13. Then P5 will be executed till 14. It goes off. Is the Gantt chart clear?
Yes, sir.
Yes, sir.
So now 0, 0, 1, 2, 3, 4. 1, 2, 3, 4. Exit time of 1 is 7. Sorry.
13 over there.
P1. This is P1. 13. P2 is 12.
11.
2 is 12. And P3 is 5, P4 9, and P5 is 40. So TAT is 13, 11, 3, 6, 10. Waiting time. Waiting time is 8, 8,
20.
9. 6 minus 2 is 4. 10 minus 3 is 7. Okay. So average, what was the question? Average waiting time.
29.
And your TAT, what is your TAT?
43 by 5.
43 by 5.
Very good. Is it clear? So try at home. Question number 1. PQ is to calculate average TAT and average WT. Question number 2. Here we have TQ is equal to 3. Calculate average TAT and average waiting time. So this is question number 1. This is question number 2.
So can you please show question number 2?
Just a minute. So total how many try at home, including the last class? 1, 2, 3, 4. Okay. 4 questions are there. In the next class, I will discuss the solution. I will share the solution. You can match your answers. Okay. And also, now we are left with 2 things: parity and HRRN. So parity, sport primitive, non-primitive, and parity can be static and it can be dynamic. What do you mean by that? Static and dynamic parity. So parity, what is parity? Parity is an integer number. Okay, so if the parity of the process does not change it throughout the process, okay, throughout the execution time, then we call that parity as static. There might be an instance the parity of the process keep changes at regular interval. Okay, then we will say that parity is dynamic in nature. Is it clear what do you mean by static and dynamic parity? So parity is nothing but it is an integer number assigned to a process, which can be static and dynamic. So in next class, we will be seeing examples of parity, HRNN, and also one more example, and that will end our scheduling. Along with that, also I will discuss these examples. Try at home.
Sir, please explain dynamic priority once.
Dynamic priority, just say for example, okay, there are 2 processes, P1, P2. Okay. प्रायोरिटी एक का 2 है, एक का 3 है. Okay. So now that means what? ये static होगा. If process execution, during the process execution, if these 2 values remain same, 2 and 3, then we will call it as static priority. Now there might be a scenario where the priority changes. Changes mean, suppose P1 is executing, it is primitive, okay, and P2 is also primitive, okay. After preemption, the P1 and P2 priorities are changed to 1 and 2. So what we have? So 2, 3, we have changed priority to 1 and 2. So what is happening during the execution of process? During during this execution, when the priority value changes of the process, say P1, P2 was having 2 and 3 at the beginning, but during the execution time, during the execution, what happens? Its priority has changed to 1 and 2. Then what we call? We call it as dynamic priority. So priorities are calculated during the execution of recalculated during execution of processes. So if the priority is recalculated during the execution of processes, we call it as dynamic priority. If the priority is not recalculated, then we call it as a static priority. Is it clear?
Yes.
Excuse me, sir.
Yes.
Sir, so the priority and round robin scheduling, was that dynamic as well?
No. Priority and round robin is completely different. Round robin means I will be preempting the process after the time quantum. Okay. Priority says I will be preempting the process if a higher priority process comes. See, for example, P1, P2, P3. Priority is 5, priority is 4, priority is 3. What happens? What will happen? Who will go to the CPU first? P3? Yes or no?
Yes.
P3 is CPU. What happens if P4 comes with priority 2? What will happen? This will be out. CPU will have P4. If again it comes with priority 1, what happens? This will have P5 like this. Yes or no? So it says that whenever there will be a higher priority process, I will be preemption. So what is happening to P1 over here? It is going into starvation. Yes or no?
Yes, sir.
After P5 executes, what will happen? P4 will be executing, then P3 will be executing, then P4 will be executing, P2 will be executing. Now what happens if again after P2 execution, P6 comes with priority of 2 again? Then what will happen? Will P1 will be executing?
No, sir.
No. So P1 will be in starvation. But if I am in round robin scheduling, I have a ready queue. P1, P2, P3, P4, P5, okay, and in time quantum, if I have 2. So for 2 milliseconds, every process will get the term P1, P2, P3, P4, P5. So what happens after the time quantum? If the process has the execution time remaining, what will happen? It will go to the back of the queue like this. P5, P1. Again, if P2 is having time remaining, what will happen? P3, P4, P5, P1, P2. Again, this may change like this: P5, P4, P1, P2, P3. So what we are having, we are not going into starvation. Every process gets its turn to execute. They don't have to wait as it what was happening over here. Is it clear difference between round robin and priority?
A little bit.
Both are primitive. Okay. Is it clear?
Yes, sir. So I initially interpreted this as that the integer number of the priority changes in dynamics. So
No. See, for example, if this many processes are in ready queue and the scheduler recalculates the priority. So suppose after a certain amount of time, what happens? These 3 processes are in ready queue. It sees that P1. So P1 has been waiting for a longer period of time. It will recalculate the priority and make this as 3, 4, 5. Okay. Then we say that we have a dynamic priority scenario where the scheduler or the operating system is recalculating the priority and assigning to the process. so that starvation is not being affected. But if it is not affected to P1, it will be affected to P2 or P3. Priority can be fixed or priority can be recalculated.
Sir, in the starvation example, the priority was fixed now.
Yeah, priority is fixed. Generally, with fixed priority, we go to starvation. Is it clear?
Yes, sir.
Okay. We'll meet in the next class.
Thank you, sir.
Thank you, sir.
Thank
Thank you, sir.
Thank you, sir.
Thank you, sir.